Giving one and getting one.
Hi guys.
Hello.
Shall I start?
Yes, please.
Thank you. We all know what IoT is. IoT is like Internet of Things. Internet of Things, what it does is we have this hardware, we have this sensors, we get the data, and then we do some computer programming, magic gimmicks, and all. And then finally, what we do is we just present the data, we have the analysis, and we intelligently make the machine to serve the user. So this is what Internet of Things basically is. So I'm a guy who's pretty much interested in IoT, but the thing is, wait, I'm an Android developer. I'm Ashwin, by the way. I just saw Internet of Things some 1 year ago or something like that. But I'm a Java major guy. I know only Java and all. I wanted to start off in IoT, and suddenly, like, I thought, okay, now how am I supposed to do this? I have to start again. I have to learn Python from the beginning, and I have to do all those stuffs and research and all to build some do-it-yourself simple projects in Raspberry Pi and all. And again, I saw some projects in online do-it-yourself things. They were like simple, small projects. But I wonder how did they actually scale it? I mean, they did the project, they put it online. They said this project is nice and all, but did they actually like give it to their customers? Did they like scale it to at least 100 or 200 people? Not pretty sure about that, but I'm sure that there is one platform which you can use to do that, which is actually Android Things. Android Things is a simple IoT platform for you to maintain your apps and applications all. I went to Google Developer Days India and I actually got this kit and I started off and trying a simple app in it. I found it pretty much very easy to do it. If you are like a software developer, not much into electrical engineering and all, this should be a good start to go into it. So to put it in simple words, it's made up of an optimized Android OS. It's basically written about Linux, so you know how secure it is. So coming to that, it has secured updates. You know, basically when you're flashing the boards during your development, there is chance that you might flash what do you say, corrupt OS and all, and which might lead to the damage of the board. This guy, he ensures that the OS which we flash, it's gonna be secure. You don't need to worry about the board damages, no. And it provides library for you to access the basic hardware. You can access the mic and speakers and all. You can access the basic LEDs and all those. Supports that. This is actually the basic Android architecture. I don't want to explain too much into it. What we've done is we've added a support library for things to the Android framework. This library has the API calls. Has the functions to interact with your peripherals, basic peripherals like your LEDs and all. And this OEM development apps comes over. What is OEM is you are developing an application only for that particular product, which means for a product you can only have this one application. That's what IoT basically is. You're going to do it for a product and it's going to be only a single app. So it supports OEM applications. So getting started, I'll actually like, go into this. I want to stream screen one, not to. Sorry for the. This is the Android Things console. Thing is, we are not going to use the typical Play Store console which we have to deploy our Android apps. We have a separate console for this. This is the Android Things console. What we do is we just need to like sign up for this, and then here's where you can add a product. And you can specify the product name here, and you can specify the type of board. To say there are only currently 4 boards which are supporting Android Things. These are the following 4 boards. The specifications are here actually. So these are the following 4 boards, and these are the specifications, the architectures which support Android Things currently. It's currently in developer preview, so only limited amount of boards and architectures support this. We can select the board here. We can specify some product name, and then just leave it as default. We are going to use the Google Play Services for this, and this is the partition size. This is the partition size we are going to give for our application. Typically in Android application, an optimal one has only some 15 or 20 MB. So like 32 is pretty much good enough. Both support for 512 MB RAM actually. So among this, we are allocating 32 MB for the app. That's what it specifies. And the reason we don't give 512 MB as in total is we need some more MB for the databases and files which are to be used by the app. So we need to select the optimal is 32 MB because Android apps optimal size is 15 to 20 MB. So I think 32 is pretty much good enough. If you need more than that, I think we can go till 64 or something like that, but not the entire 512, which is the maximum which the board supports. So this is how we created. I'll just show you a sample one. So this is how it's getting created. Now, this is where you download the OS, which you need to flash it onto the board. So like currently, only the developer preview is available for this. The final version is not available as of now. We might be expecting the upcoming Google I/O or something like that. So after building this, after the build gets over, you can just download this, and then what we can do is go to the terminal. Download this tool for setting up Android Things on, flashing the OS onto your board. Just have to download the setup utility and then head up to the terminal. You just have to run this command: downloads, unzip the folder, and then browse to Mac OS or Linux or Windows. They give support for Mac OS, Linux, and Windows. Since I'm having Mac, I'm running this utility. So what we can do is we can install Android Things and optional setup Wi-Fi, or you can set up Wi-Fi on existing one. So after you give this, they're only listing 3 boards for you to like choose from. Since I have Nico NXP Pico, I'm choosing that. And here there are 2 options. You can flash the default image which is being downloaded from online, or you can download. You already downloaded one build, right? That you can specify the path here, and then you can flash that build here. The difference between default image and this is default image doesn't support the app updates and the OTA or DAR updates, while this custom image supports that. But whatever we download from online.
Are you sure it's not the other way around? Custom image does not support updates and default support updates?
Custom image supports updates. We are downloading it from online, right? Here, this is a custom image we downloaded just now.
Okay.
I downloaded the custom image from here, from where we can send the OTA updates.
Okay, so custom image supports updates. And what is the default
image? It just downloads the default image from Google, just for development purposes. Oh, okay. You don't need to like go and update it all. I'm just going to try a simple app.
Like a one-time
thing. Okay. Or you can use it for development purpose. You can't go scale it. That's it. That's the difference. Then I'm not going to show you how it's going to run because it's going to take some time. I've already set up a running one. I'll just show you a demo actually, and then it will be much more clear.
I'm ready.
Sorry. Is this visible enough? Yes, sir. Before going to this, I'll just explain what this application is. I just did a demo application for you to show. It's just gonna have a camera module. It's gonna have a speaker. It's gonna indicate the information. In Android, we have Toast which indicates the information. But then in IoT Kits, Toast doesn't look that good. So I added speaker for it. And the main demo, it's gonna be like I'm gonna take a picture. It's gonna do some inference with the Google Vision APIs, and then return the result with what that image is. I mean, approximately. So like I'll go with the demo.
Click. Photo capture in progress. Capture successful.
So basically, like, can you hold it? Go to distance. Is it visible? Visible enough? Yeah, I took this picture, okay? I mean, it looks like a speaker and laptop and all. So what it says is, it returns an inference that it's technology, electronics, electronic device, hardware, product, and multimedia. So it's just a simple IoT kit. I just wanted to show you a demo with a simple app. I did it with another app, but then it was like too complicated to explain here. So I just made up a simple demo with one activity. What it does is just takes a image capture and does an inference. We have TensorFlow for doing that, which is offline one. And I use the Google Vision APIs, which is available, which is an online one. So it does an inference based upon this. So this is just basically the demo. So going on further, so this is what basically Android thinks is. It's a platform for IoT. It's going to be secure. Don't have any viruses entering there, and your board's going to be safe. It utilizes all the Play services which is available from Google. So you can develop IoT with Android, and then we can manage. Importantly, this is what we need for scaling. We have an Android Things console where we can manage the APKs for updates, and we can also send over the air updates for even the OS for its update. So we have that. So current state of Android Things is currently it's in developer preview. We can start building things in Android and IoT. And once the live version goes off, I think we can see a big boom, and we can see many products coming up in Android things. So it's so simple. It's for the software engineers who are like pretty much scared of electrical stuff and all. So I actually wrote a Medium blog on how to start off with Android things, and then it has a GitHub link as well. So the complete project is on GitHub, so you can refer that, and you can follow me on Twitter in this hash. So I've done with my talk. This floor is open for questions.
Okay. So when I saw the boards,
Okay.
these are all ARM64 boards.
Yeah.
Right.
Yeah.
Which are basically microcomputer.
Yeah, microcontrollers.
Microcomputer.
Oh, microcomputers.
So this does not support microcontroller like an Arduino or an 8036 or something like that, right?
Currently, it doesn't support
Doesn't
Arduino.
support.
It supports Pico board and Raspberry.
Okay. So what I'm thinking is, if you take a use case, for example, say you want a customizable home automation system.
Okay.
Right. So your Raspberry Pi or an XP